So in today's session, we'll be discussing about how do we achieve true scalability for relational database management system in zero downtime. So we'll talk about the following topics in today. We'll address the challenges in legacy database infrastructure using GCP DB offerings. After that, we'll move to leverage industry-leading open source tools in order to scale your read workloads. Following which, we'll be discussing about how do we manage the splitting of read-write transaction in the database. And last but not the least, we'll also focus on the technical overview about Cloud Spanner, which is a globally distributed new SQL database created by Google. We'll start with the first topic, which is legacy-based infrastructure. In the current infrastructure that we have, the challenges that we face is primarily with the splitting of read and write workloads. Okay, why when you scale your databases? So right now, what we have with us is we have one master and multiple slaves, or we can have one master and one slave. So what is the need for us to scale the databases? There are two requirements. One thing could be we have outgrown our requirements. The other thing could be we plan to scale our database for better efficiency. Okay, or if there is an unexpected workload. So if we discuss about both the requirements, the first one, unexpected workloads, if you plan to scale your databases, you need to consider three factors: hardware infrastructure, technical overhead, and the downtime involved. If you talk about the hardware infrastructure, right from provisioning a virtual machine or maybe setting up a new physical system, there is an hardware cost involved into it. Okay, right from installation of the operating system to the installation of a database onto that operating system, everything is based on a hardware infrastructure, and that does require some investment. Second thing is we'll move on to the technical overhead. All the things that we just discussed, provisioning a VM, setting up a physical machine, installing of operating system, everything has to be done by a technical person. And that does require a technical overhead. That does include a technical overhead. Okay. The third one, there is a downtime involved. If at all you plan to scale your databases, you cannot do it very easily without downtime. So there has to be some amount of that downtime that will incur when you scale your databases. Let's discuss about the challenges with the legacy-based infrastructure. The challenges with the legacy-based systems are such wherein the read and write traffic from the application server are either not distributed between the master slave server efficiently, or if you want to distribute it, we are supposed to make the changes in the application code itself. If you are trying to make the changes in the application code, that will require a good expertise to make the changes. Okay. Also, it becomes a very technical overhead for you to go and change your application code every time if you want to change the IP address of the master and the slave. In simple words, managing the MySQL replication topology becomes difficult. Okay, and you would require a dedicated DBA team in order to manage that. If you are hiring a particular DBA, that will incur cost, and the DBA will be able would be responsible to manage your monitoring, backup, and recovery. Okay. Also, if you set up a proxy layer in between, even that adds an overhead for the database administrator, and he's supposed to look after that also. Next, we'll move on to the horizontally scaling legacy-based infrastructure. When we talk about scaling, it is only possible for us to scale the read servers. I agree. You would say we can also scale the write databases. That is correct. But scaling that particular server, the master server, would require a lot of complexity to be solved. However, we can definitely scale our databases horizontally using some open source tool available with Google Cloud Platform. And if you want to list those open source tools, we have Proxy SQL for MySQL, and we have PGPool as a tool when it comes to PostgreSQL, which you can provision and you can use them in order to scale your databases efficiently. Let's discuss about Proxy SQL first. Proxy SQL is basically built for MySQL in particular in order to meet the MySQL scalability and in order to achieve high availability goals. What it provides is it provides an intelligent load balancing application. It is an intelligent load balancing application which automatically diverts the read and write traffic to the master and the slave servers. It understands by from the application that this is a particular query. If it is a insert update delete command, it should go to the master, and if it is a simple select statement, it should go to the slave server. So this particular software helps us to manage the read and write workload efficiently. Also, you can provision this proxy SQL server in HA mode so that it is not a single point of failure, and we can achieve scalability as well. Similarly, for PostgreSQL, we have PGPool. PGPool is a software that sits between the actual PostgreSQL database and the Postgres database client. It has the following features. It has its own replication feature in which it reduces the load on each PostgreSQL server. What it does is it distributes the select query among all the available servers, and eventually the throughput of the entire server is increased. Okay, it also makes sure that each and every server is reachable by the PG pool server. Just in case if it identifies that one of the servers are down, what it does is it promotes the other server as the master server, and there are some very sophisticated features that helps us to perform this automatic failover. Moving on, we'll see how working with proxy SQL with Google Cloud is. Okay, so as we discussed in the legacy system, we have configurations such as one master and many slaves, or one master and multiple slaves, right? So instead of we going there and making the changes in the application code so as to determine which particular server this request will go to, what we can do is we can simply set up a proxy SQL server in between of your application and the database server, and its intelligent feature will understand the type of query that is coming from the application, and it will divert the load accordingly. The write will go to the master and the read request will go to the slave. Now, what is that is needed when you want to migrate your on-premises data to Google Cloud? So we are just assuming that we have one master server and one slave server, or we could have one master and multiple slave servers also on-premises infrastructure. Okay, so what you need to do is you need to create one more slave server, or you can use our existing one. Take a dump from that database server, from the slave server, and restore it onto a Cloud SQL instance. Okay, and once the restoration is completed, you can simply provision the new Cloud SQL server as the slave server to your already existing master server. The only requirement here is when you set up a master slave server at on-premises infrastructure, that time the setup should be with replication GTID enabled. And in this way, you can migrate your on-premises infrastructure to Google Cloud SQL. And when you want to switch over, we can simply promote this current Cloud SQL instance, which is right now acting as a slave server, and we can promote this server as a master server. And if you want, you can also create read replicas out of this. Moving on, I'll ask my friend Benjamin to explain you guys in detail how Cloud SQL works at the backend and how Spanner works at the backend.
Story of another day. And moving further to the right, you can see that we also work very closely with many strategic partners. So if you are using MongoDB or Redis, you can also run those on GCP managed by the partners. Or even further to the right, there's like some of the other kind of on-premise or traditional databases that you can use, as I mentioned initially, on Google Compute Engine or even Google Kubernetes Engine if they support that. But now let's focus on the red box. So today we're talking about relational databases, how to scale them. And traditionally, the kind of Cloud SQL, yeah, perfect, Guldeep, if you can go one slide further. Cloud SQL is a fully managed relational database service, which you can run kind of all your traditional SQL instances, so either MySQL that supports, or PostgreSQL or SQL Server in the cloud. And when I say fully managed, if you can go to the next slide, it comes with a few key benefits. And let's look at each of those to make sure it's very clear what is supposed to be meant by those. So first and foremost, for performance and scale. That's the topic of our discussion today. So that means you can scale your database from up to 64 processors and 400 gigabytes of RAM, which can lead to a database of up to 10 terabytes in size. So keep that in mind. The Cloud SQL operates in the realm of terabytes, as we will later talk about a solution that is a level higher on the petabyte level, but for Cloud SQL, up to 10 terabytes, you're good. It's also super secure, so we have automatic data encryption at rest and in transit. You still control all the firewall settings, and we are also compliant with most industry standards. When it comes to reliability and availability, it's super easy to create a backup, or as Guldeep mentioned before, like a read replica is also quickly done. We also have a feature that we call automatic failover, so that if there would be any issue, we make sure that there's a replica in place that you have always access to your data. And also it is fully integrated with many of other Google Cloud Platform solutions. Just to name a few would be App Engine or Compute Engine, but also with any of your on-premise systems, which we'll actually see a little bit later. Looking at the second row at the bottom, in terms of compatibility, as I mentioned before, it just does support MySQL, currently 5.6 and 5.7, and PostgreSQL at 9.6, with all the standard connections. It is what we call fully managed. So that means you don't have to worry about installing the software, you don't have to worry about data backup or maintenance. And we also have several alerts and monitoring tools integrated that allow you in a quick and efficient way to keep track of the performance of the database. Also, what I think super nice feature, not like I think there's many cloud tools, is the pay-per-use. So you don't have to provision any hardware upfront, which is either too big or too small. You'd only pay by the minute. And there's also no login or no upfront payment required. So really, you just pay for what you use on a minute basis. And automatically, we will apply a sustained use discount. So that means if you use it for like a sustained amount of time, let's say 30 days out of a month, you can earn kind of discounts based on how much you use it. And lastly, we do leverage many GCP partners that we also kind of saw on previous slides to make sure the product is well integrated into your streaming pipelines, and also in terms of not just how you get data into Cloud SQL, but also how you get it out. We have a lot of connections and connectors to visualization tools. Okay, if you can go one slide ahead, please. So as I mentioned previously, we want to make sure that you can use Cloud SQL almost like independently of the rest of the cloud platform or Google Cloud Platform. So we have several integrations, of course, with other GCP products. And that's often the use case, that people wouldn't just use the SQL part of Google Cloud, but theoretically, and it is supported, that you can connect your applications that are running outside of GCP using standard MySQL or PostgreSQL protocols. Yeah, I think that's enough for this slide. But now let's move on to a product that, for this audience, it might be a bit like a next step or a bit too high. So we call it Cloud Spanner. It's an enterprise-grade, globally distributed, and strongly consistent database. So I'm just mentioning this up front to be very clear. It's more like an outlook. What else is technically possible? But keep in mind, it comes at a cost. So you might not, even though you might like all the features, you might not actually want to pay for it. And that's why we have people like Kuldeep and experts that can help you build something similar using open source tools and maybe in a bit more affordable way. But I think it's good to know that the technology exists to even scale a relational database horizontally. And we will look at this in more detail going forward. So if you look at the next slide, you can see that what's this kind of special thing about Cloud Spanner is that it combines relational semantics with the ability to horizontally scale. And this is kind of quite unique because usually there are certain limits, like the benefits of a relational database, like the fixed schema and the speed that it comes with. They, on the other hand, on the kind of other side of the medal, have the downside that it's very tricky to scale this horizontally or make any schema alterations later on. So if you kind of just look at exactly, could it be already on the right slide? Perfect. So we kind of can see here in this table, you can kind of see how Cloud Spanner combines benefits from relational and non-relational databases. So when it comes to, Cloud Spanner does have a schema. It allows you to kind of use SQL language. It is strongly consistent. So far, it's very much like a traditional relational database, but it has a high availability. It is horizontally scalable, and it has automatic replication, which usually you wouldn't find in a traditional database. And all of this we provide at 5 nines SLA. So we basically have no planned downtime. You get all the enterprise-grade security that I mentioned before. Okay, so you might now be wondering, well, you can promise us as much as you want, but how do you actually achieve that? So if you look at the next slide, don't worry, I won't go very deep, but just kind of to give you a rough idea how we do it and also maybe why it's so expensive. So basically, it leverages the Google's global network infrastructure in combination with very accurate timing, which we call true time. It's a combination of GPS timing and an atomic clock. So each of the devices that we can see on the right-hand side has its own atomic clock integrated to ensure the synchronization is as accurate as possible. Nevertheless, as you might, anyone kind of more familiar with the topic might know that it's very tricky to get like a perfectly synced global timestamp. So there is a little bit of wiggle room, of course, but we do kind of account for that, and that's why we use the optimized software stack that is able to deal even with these slow intervals, like small intervals, instead of a single timestamp, to achieve a what we call strong consistency and a global serialization. So whenever there's a write happening on the database, regardless where it is, the order of the writes will always be maintained, even at a super high speed. Even when a read happens, you can be sure it's reading the latest update and not nothing gets lost even around the world. So if you see on the next slide how we kind of why this is something only Google might be able to provide, because we have one of the largest networks in the world. We actually build these networks. We own all the cables, and they're optimized for operations like the ones we just saw, the Cloud Spanner operation. And only with the combination of these super accurate timing and the very strong network, we are able to provide the global consistency. If you look at the next slide, just as a summary, what we can see here is, so kind of Cloud Spanner allows you to scale a relational database horizontally, either regional or even multi-regional with transparent synchronous replication. So that means we would, with monitoring tools and also by like looking at how we do it, it will be very clear to you that the order of the events or of write operations is maintained. There's no maintenance window. It's also important to know. We can also separate, what we allow you to do is like to separate the storage and the compute. So you basically only need to scale the storage part, and the compute is kind of separate. And you don't like, yeah, you kind of can use any of our offerings there. It could be compute engine, app engine, or even Kubernetes container-based applications. You can change the schema online. And I think what super important to point out is the last point. As I mentioned before, Cloud SQL allows you to build a database up to, like for one instance only. Of course, you can have multiple instances, but one instance can scale up to 10 terabyte, while the Cloud Spanner can scale in the petabyte range, which of course is another level higher. I think content-wise, we're quite like have a good overview now, and we want to, as we heard in the beginning from Pawan, we want to open the floor for questions. But before we kind of maybe open it for general questions, I brought a few kind of frequently asked questions on the next two slides. So Kudip, if you can go one slide further. We can maybe look at some of the common questions. Hopefully this answers already some of the questions you might have. If there's anything left open, feel free to ask them as soon as we are through with the content. So as I mentioned before, how does it work with the replication delays? So effectively there's none. Theoretically, yes, there are a few milliseconds delay, but the whatever read you want to do, it keeps this in mind. So when you send the read, it keeps in mind that this might be a write kind of still being done. It's already committed. So yeah, like when you use it, there you might feel a few milliseconds of replication delay, but it's more a theoretical thing than anything you would hinder the performance of your application. Also, for those of you who are familiar with our offerings, and we saw that on this overview slide in the beginning, that there's many different database solutions, and often it's not that easy to pick which one is the best suited for your application or your needs. So when it comes to differentiating Cloud Spanner from Cloud SQL that we already saw, or Cloud Bigtable, kind of you can see that Cloud Spanner is this transactional, so relational database with no downtime, while SQL is, and also, sorry, Spanner, the main point is it's scalable, like fully scalable, while SQL is also transactional, also relational, but has a limited scalability, and occasional maintenance might be required to update to another version or update the schema. And then Cloud Bigtable, it's a non-transactional database, so in the NoSQL area with low latency, and it's not queryable. So it's more like, yeah, we use it for, let's say, financial applications to store data. Okay, if you look at the last slide, just to get like an idea of what other questions there might be. So as I mentioned before, why is it so expensive? I hope by shedding a little bit of light behind the scenes, it's more understandable now that it's just a lot of effort required to achieve this globally scalable relational database. So yeah, it's the network needs to be powered as well as these super delicate hardware components. Overall, we still believe that it is competitively priced, maybe not for a small application, but in the enterprise space, it is probably a lot cheaper to use Cloud Spanner than trying to build something similar at this scale yourself. And just also in case you have been wondering, it is ANSI SQL compliant, and it is really relational. So you can use joins and any SQL language that you maybe already have available. That's it. That sums it up from the side on Cloud Spanner. As I mentioned before, the idea was to just give you a bit of an outlook of what is possible with cloud technology. I don't expect any of you or all of you to adopt Cloud Spanner today or tomorrow, but kind of keep it in the back of your head that this technology exists. And with many of these things, without promising anything, but over time, they might be more accessible. And when it comes to designing your applications, like keep it in mind, there is a possibility to use something like Cloud Spanner. For many use cases, Cloud SQL might already be a good solution as well. And in any case, we always super supportive of open source solutions, including those two that Kuldeep mentioned.
Thank you for joining, and Benjamin, thank you for your time as well. And Kuldeep, thanks for sharing your knowledge.